I've talked so far about unreinforced concrete and then about reinforced concrete. Now I want to go ahead and add the concept of pre-stressed concrete to our discussion. To start understanding this concept, you need to understand the difference between what I'm going to call active reinforcing and passive reinforcing. So far, I've only covered what we call passive reinforcing. We call it passive reinforcing because essentially it sits inside the concrete and it has no effect on the concrete structure until the concrete's loaded to the point where it can't take it anymore, and then the rebar takes over. So in the case of bending, that rebar feels nothing until the tensile stresses in the concrete exceed its tensile strength and it starts to pull apart and crack. We locate the rebar as close as possible to the face of the concrete where the tensile stresses are going to develop, so that crack travels only a very short distance before the rebar takes over. Same thing goes with temperature and shrinkage reinforcing. The rebar does nothing until the concrete shrinks enough to start pulling it apart. Then the rebar takes over and holds those cracks closed. This is an important concept to acknowledge because it helps us to understand that concrete is going to crack. If it cracks like we expected, and that cracking is managed to the degree that we intended, then the design and construction worked. If the cracks occur in unanticipated locations, then maybe something went wrong. Maybe the designer specified control joint spacing that was too far apart, and you end up with cracks between those control joints. Or maybe the reinforcing wasn't placed securely and it floated up to the top of the slab when it was needed in the bottom portion. Now, these would be undesirable conditions and they might warrant some corrective action. But again, just because we see cracking, especially hairline cracks, it's not always a sign of a deficiency. Remember, it might actually be doing what it's designed to do. Concrete shrinks, and that's the way passive reinforcing works. Let's talk about a different concept, though, and look at active reinforcing. Active reinforcing of concrete is achieved by pre-stressing the concrete by using pre-stressed reinforcing steel. As the name implies, this is a technique that involves putting some internal stresses in the concrete before the concrete's loaded, or before it moves and shrinks or bends. The idea here is to get some beneficial stresses into the concrete. And since we've already established that concrete's really strong in compression, that's what we want to do to the concrete. We want to put it into compression. We already talked about compression being forces that squeeze concrete together. So if we combine all these things, we pre-stress concrete by squeezing it together before it has the chance to move and crack. Think about the benefits here. If I can squeeze my concrete slab together with enough force before it shrinks too much, and I keep squeezing it while it shrinks, we let it shrink, but we prevent it from cracking. And since this is active reinforcing, we leave this force squeezing the concrete together forever. This actively puts the concrete into compression, which increases the bending strength of that concrete slab or beam itself. Now, if that concrete shrinks or bends, it has to build up tensile stresses that are greater than the sum of the tensile strength of the concrete plus that additional force we put there by squeezing it together. Let's think about picking up a stack of books. If I have a bunch of books and I pick them up by squeezing the stack together and I lift it, the more I squeeze, the less likely that stack is to come apart. Or look at it another way, if I squeeze harder, I can lift more books. This sort of illustrates the concept of squeezing the concrete together. As you might imagine, pre-stressing is a little more complex than just installing rebar, so let's continue and look at how we actually do this.